Hey folks, welcome back to DevLayer. Today we are diving into one of the most powerful design patterns in low-level design, the decorator pattern. This pattern helps you add behavior to objects without modifying their original code. We'll even see how it connects with TypeScript decorators in the next videos. So let's get started. The decorator pattern is a structural design pattern. It allows us to wrap an object to add new behavior dynamically while keeping the core logic untouched. You can think of it like toppings on a pizza. The base remains the same, but we can keep adding layers of flavor. Similarly, we can decorate our objects without changing their original structure. This is really useful when you don't want to clutter the original class with multiple responsibilities, like logging, retries, or caching. Let's say you have a simple notification service that just sends a message. Now your manager asks you to add logging, then they ask for retry logic. Later maybe database logging. Over time, this single class starts doing too much and violates the single responsibility principle, as well as the open close principle. It becomes hard to test, hard to maintain, and very easy to break. Instead of modifying the class, we can wrap it using decorators. You start with your notification service, then you wrap it with a logging decorator, and then wrap that with a retry decorator. Each decorator adds a behavior without touching the core logic. These decorators are just classes that implement the same interface and delegate to the wrapped object after adding their own logic. As you can see in the diagram, this is like a stack of wrappers. And when you call send, the request goes through all those layers one by one. Let's take a look at the code. We define a simple notification interface with a send method. Our notification service class implements it. This is our base object. Then we create a logging decorator implementing the same interface, which logs the message and forwards it to the wrapped object. Next, a retry decorator also implementing the notification interface, which retries the message up to 3 times by forwarding requests to the wrapped object if it fails. Finally, we wrap the base service in both decorators like this. We create a base object using our notification service class and wrap this base object inside our logging decorator to add the logging functionality. And then wrap this object inside our retry decorator to add the retry functionality. And finally, we call the send method on this object. When we call send, we see the decorators in action. Logging comes first, then retry logic, and finally the message is sent. Here's what the output looks like when we call send. First, the log is printed by the logging decorator, then retry items are shown, and finally the actual message is sent. This shows how each decorator works independently but still fits together in a clean, modular way. Now that we have seen how the decorator pattern works, let's look at some real-world scenarios where this pattern is incredibly useful. One of the most common places I have seen it used is for logging. Let's say you have a service that sends emails or notifications, and you want to log every time a message is sent, but you don't want to clutter your main code with logging statements. That's where a logging decorator comes in handy. You just wrap your service and it logs everything behind the scenes. Another great use case is retry logic. Imagine you are calling an external API and sometimes it fails due to a network glitch. You don't want to write the same retry logic everywhere. Instead, you can wrap the service with a decorator that automatically retries a few times if something goes wrong. Clean and simple. And if you have worked with web frameworks like Express or Nest.js, you have already used decorators. You just may not have realized it. Middleware is basically a chain of decorators, each one adding a layer like parsing the request, checking for auth, logging, and so on. Speaking of auth, decorators are perfect for authorization. You might want to restrict certain actions to admins or premium users. Instead of putting permission checks everywhere, you just wrap your logic with an access control decorator. Rate limiting is another good one. Say you want to stop a user from hitting your API too frequently. You can just wrap the endpoint with a rate limiter. It keeps your actual logic clean while still protecting your app. And one more I really like is validation. Let's say you have some user input, maybe a form. Instead of stuffing all your validation inside the main function, you decorate the function or method to handle that separately. Again, way cleaner. Finally, in security sensitive apps, I have seen decorators used for encryption. You decorate methods or properties so the data is automatically encrypted when saved and decrypted when read. The core logic doesn't even need to know. So yeah, decorators are everywhere. They're like little wrappers that quietly do their job without getting in the way. Once you start thinking in decorators, you will find they help keep your code modular, testable, and super maintainable. Now that we understand the decorative pattern from a low-level design perspective, in the next video, we'll explore how TypeScript decorators give us a powerful, elegant syntax to apply this pattern in code. We'll cover method, class, property, and parameter decorators, all with real examples. To summarize, the decorator pattern helps you add behavior to objects in a modular, testable, and scalable way while keeping the core logic untouched. It also supports the open close principle. That is, it helps you to keep your class open for extension but closed for modification. It is very useful in building large, flexible systems like notification pipelines, form validators, or middleware chains. If this helped you, give it a like, subscribe, and hit the bell icon so you don't miss the TypeScript Decorators video coming up next. Thanks for watching. See you in the next one.